You might have heard about the term particle accelerator in movies or general media. You might have even also heard about the resulting discoveries such as quarks, but all of this can be a little confusing if you're not able to firstly answer the question, what exactly is a particle accelerator? Actually, the answer is pretty simple. Firstly, this might sound a little boring, but I believe it very important to have at least a rudimentary understanding of particle accelerators, seeing as how they are without a doubt the biggest invention to understand physics since the invention of the microscope. To give a little credibility to my statements, I can tell you that all the research that has been done for this video has been done through articles written by the most respected and well-known organizations and magazines in science, such as the US Department of Energy, the CERN Science magazine, MIT School of Engineering, and the International Atomic Energy Agency. Okay, now that's been dealt with. According to the US Department of Energy in 2014, a particle accelerator on a basic level produces a beam of charged particles used for a variety of research purposes. These particles are typically protons and electrons, but let's backtrack a little bit. Since all of this seems a little complicated, I'm going to explain it step by step. Firstly, as read by the US Department of Energy, the main purpose of particle accelerator is investigation. Now, mainly this investigation focuses towards understanding the inner functionings of particles, and with it, listen to this, understanding the inner functions of our universe, and possibly even its origin. Impressive, right? But how can a particle accelerator do all this? Well, let me explain to you how it works. Firstly, particle accelerators do exactly what the name says. They accelerate particles. And the velocity with which they need to accelerate them is nearly the speed of light. More specifically, 99.9% the speed of light. But how exactly can particles be accelerated to these great speeds? Well, according to CERN Magazine of Science, the way that particle accelerators do this is by generating electric fields in order to accelerate the particles and magnetic fields to be able to navigate them. So, in short, how particle accelerators move their particles is through electromagnetic fields. It's also important to remark that particles must always travel in a vacuum. Okay, now I'm going to explain to you the actual process of how it works. To understand this in the most basic way, you must know there are two types of particle accelerators: linear particle accelerators and circular particle accelerators. Linear are, a little more simplistic, less complicated. Basically, what linear particle accelerators do is they take the beam of particles and accelerate it through electromagnetic fields and then crash it directly into an object. I mean, pretty fair and simple. But the interesting part comes from the circular particle accelerators, in which they accelerate the particles in a circle, similarly to cars running laps around a track. So they accelerate them to nearly the speed of light, and then they crash them. Sometimes they crash them against objects, but the very interesting part about circular accelerators is that a lot of the times they crash them against other particles. So, to explain it more simply, imagine that there are two cars in a racetrack. They are running opposite to each other. And then, when they reach their top speed, they crash into each other. That's basically how a particle accelerator works. They cause a collision of particles in order to be able to study what's inside them. Similarly to how the cars crash and a lot of the parts that are inside the cars fly out, the same way particles collide into each other at great speeds and other particles inside them are revealed. That's how we discovered quarks and Higgs boson particles. To put you in a little context, protons and electrons are already subatomic particles. Protons are positive energies and electrons are negative energies. and they were believed for the longest time to be the smallest subatomic particle in existence. But thanks to particle accelerators, we discovered that was false. There are even smaller, much smaller particles inside them. As a matter of fact, this discovery led to a very famous physics theory referred to as string theory, which referred to quarks, the smallest particle now known in existence, not being actual particles circular, similarly to how we believe everything else to be, but actually strings that connect with each other. In physics, it is somewhat believed that these strings vibrate and make it possible for other universes to exist and be interconnected with ours. But I'm rambling on. Basically, what I'm trying to tell you is that particle accelerators have the purpose of better understanding particles, in turn giving us a better understanding of our universe. But physics is not the only field where particle accelerators have made a great advancement. Take medicine for an example. Without particle accelerators, the use of X-rays would be impossible. See, the way that particle accelerators help X-rays is that when a collision is caused in particles amongst other objects, one of the things that are released is a giant surge of energy, more specifically radiation. So if you remember correctly, X-rays are radiation, and thus we can have a better understanding of the human body and diagnosis than ever before. Now, particle accelerators sound like very intricate and very large structures. And as much as this doesn't always have to be the case, it is largely stated that the parameters for making a functional and practical to study particle accelerator, it needs to be rather big. As a matter of fact, the MIT School of Engineering stated in 2008 that the size of the magnetic rings and the ability to navigate the magnetic field make it almost impossible to make a practical yet small particle accelerator. Now, from what I said about particles colliding and creating radioactivity, you might have also guessed it. Another one of the uses of particle accelerators is the study of nuclear energy. Now, as bad as those two words sound, nuclear energy is actually the answer to a lot of possible problems. It could potentially save humanity in the future with a clean energy source. Now, to conclude, the use of particle accelerators have made an advancement in our society and expanded the limits of science beyond every expectation and given us amazing things along the path, such as already mentioned, new energies, medical uses, and definitely research purposes. Now, if this doesn't convince you and physics just isn't your thing, now you at least have a very interesting conversation topic.